What's up, Algebra 1? We're going to do lesson 89. We just have a couple more left this year, so hang in there. Here we go.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 89. We are going to talk about value problems. We've already talked a little bit about this when we talked about coin problems, but we're just going to do more of the same thing with that, okay? So let's just dig into it. Let's go to example 1 first. Airline rates for flights from Tifton to Adel are $30 for first class, $25 for tourist class. Okay, so let's see. Let's just write that information down. I'm not going to copy the whole problem down, so we're going to say $30 for first class, and then $25 for the tourist class. Okay, so if we remember our coin problems, nickels were 5 cents, dimes were 10 cents. So this is kind of the equivalent. First class tickets are $30, tourist class are $25. So you can have the number of tickets, but then the value of each of those tickets. Okay, so if a flight had 52 passengers who paid a total of $1,360, how many first class passengers were on the trip? Okay, so we're going to do two equations. We're going to do a quantity. Okay, so let's say that our F stands for number of first class passengers. Okay, and then our T stands for number of tourist class. Okay, so if there are 52 passengers, we're going to say F plus T equals 52. So number of first class plus number of tourists equals 52. All right, there's not any other type of passengers. These are the only. We don't know how many first class yet, and we don't know how many tourists yet. But we do know that the total paid was $1,360. So if we calculate our value, so this is our quantity equation. Now we're going to do a value equation. Okay, so if the value, if the total was $1,360, so this is how much money they brought in. So you calculate the number of first class passengers, they had to pay $30 a piece. So it's 30 times the number of first class passengers plus 25 times the number of tourists. Okay, so if you add all that up, it should come to 1,360. All right, now we have two equations with two variables in it. I could use substitution or elimination. I think let's use substitution. So F equals 52 minus T, or you could say T equals 52 minus F, doesn't matter. So now we have an expression for F that we can plug in right there. Okay, so let's do it. 30 times our F, which is 52 minus T, plus 25T equals 1,360. All right, let's do that. Let's see, that's 1,560 minus 30T plus 25T equals 1,360. Combine like terms. Remember, we're just solving equations here, so this is negative 5T. All right. All right, get rid of the constant on the variable side. So then we end up with negative 5T equals, let's see here, that's negative 200. All right, last step to solving equations, divide by variable's coefficient. So we're dividing by negative 5, which works out nice because we don't want negative passengers. So negative 200 divided by negative 5 is positive 40. So this is the number of tourists. So what is our number of first class passengers? That's just 52 minus whatever T is, which is 40. So we have 12 first class passengers. All right, that's cool. So you're always looking for two different equations. We have a quantity equation and a value equation in this example. Let's try another example. Here's example 2. Example 2 says, Wataksha. I don't know who that is. What are you thinking, John? Wataksha. Anyway, their dress shop sold less expensive dresses for $20 and more expensive dresses for $45. Okay, so I'm gonna say expensive is the number. E is the number of expensive dresses. Okay, and L is the number of less expensive dresses. And these guys are, what are they? $45 a piece. $45 each. And these guys are $20 each. All right, so then the next sentence says, the shop took $1,375. Okay, so that means the total after selling all of their expensive dresses, not all of their, some expensive dresses and less expensive dresses. So let's calculate the price of each. So this is the value equation. So we multiply the number of expensive dresses by 45, and we multiply the number of less expensive dresses by 20, and that has to equal $1,375. Okay, here's what else it says. The shop took in and sold 20 more of the less expensive dresses than the more expensive dresses. Okay, so that means our less expensive dresses are 20 more than our expensive dresses. Okay, so now we've got a value for L to plug in. So we're going to plug that in right there. So let's rewrite this equation. 45E plus 20L equals 1375. All right, first step, solving equations, simplify both sides separately. So we're just going to distribute. That's the first part of simplifying. So that's 400 plus 20E, and that still all equals 1375. Next step to simplifying both sides separately is to combine like terms. So this is 45E and 20E is 65E plus 400 equals 1375. All right, first, and then the second step to solving equations is if you have variables on both sides, get rid of the smaller one. You don't. So let's go to the third step of the equation, solving equations, which is get rid of the constant on the variable side, which is this guy. So get rid of that. And you're left with 65E equals 975. All right. Divide both sides by variables coefficient. That's step 4. So divide by 65. And E equals 15. Okay. So if E equals 15, how do you figure out what L is? Well, L is 20 plus whatever E is. So L equals 20 plus E, which is 15, so L equals 35. So you have 15 expensive dresses and 35 less expensive dresses. Cool. So there's really not anything too different about that. It's just like our coin problems, except instead of 5 cents for every nickel and 10 cents for every dime, it's $45 for expensive dresses and $20 for less expensive dresses. Okay? Does that make sense? Good.
Flack man, give me some math and I'll give you some flack. Flack man.